All right, continuing from previous video, this is part 2 of the different section 1 through 3 problems. Here we are asked to write a neutralization reaction. That is also term for acid-base reaction. And we talked about an acid-base reaction or a neutralization reaction forming both salt and water. So we need to figure out what we've got here, and then we need to figure out how we're forming those things. And one of the things I want to remind you of here, and it becomes really useful later on, is that water can be written as H with a hydroxide ion. Okay, so the proton and the hydroxide. And we're going to get into the habit of leaving them like this because a lot of times when we do acid-base chemistry, we lose track of a proton and it's kind of a disaster. And then it's hard to see that water actually has one proton and one hydroxide ion, not two protons and an oxygen atom. And that being said, let's start down here. First things first, knowing what the acid and the base are going to be very helpful. And you'll remember from our definitions that we said Arrhenius dictated that an acid is a proton, an H plus concentration increaser, and a base is an OH minus concentration increaser. We also then learned that Bronsted-Lowry is a proton donor and acid, and that a Bronsted-Lowry base is a proton acceptor. We also looked at memorizing the common acids and the common bases. And one thing I want to draw to your attention is that when we talked about the bases, we said that they were hydroxides of group 1 and some group 2 metals. So this guy must be the base because it has the hydroxide, which makes this the acid. And of course it's also acetic acid. You can probably tell from the names that this was going to be the acid and this was going to be the base, just because it's not the acid. In this case, we have to figure out what proton and what hydroxide ion are going to join together. And I do want to point out to you that in acetic acid, this is the acetate ion. Right? It's a -1 charge, and then the H that's attached to it is the proton. So when we break this apart, we're going to take this proton and we're going to take this hydroxide. We're going to join them together to make water. Okay? And one of the things you'll notice is that I have two hydroxides here, but only one proton here. So when I go to form my water, which I know is one of my two final compounds, we're just going to leave it like this. We're not going to add extras or anything like that. We're not going to try to balance it until the end. The other thing that I know is that since this is a +1 charge, that hydroxide is also a -1 charge, and there are two of them, what I know about barium is that it has a 2+ charge, and I know that this acetic acid, using the clues that I have, is a -1 charge. So when I join these two together, so I'm doing a double displacement reaction just like I did before, but I'm forming, one thing is always going to be water, one thing is going to be the salt that includes the leftover ions. So I've got barium 2+, CH3COO-, 1, I'm going to do my cross C, and I'm going to get barium acetate, which is going to have a 2 after the CH3COO-. Okay? One thing I'm going to do, I'm going to try to move that. I haven't done that in a long while. Pretend that this is up here. That being said, now I'm going to go through, and I know that since this is a salt, it's going to be aqueous. One of the rules of these types of reactions is you can't form a liquid and a solid. So this is not a combination precipitation or anything like that. This is just going to be a straight, this is like your precipitant and this is like your leftover salt. You should always have one aqueous and one liquid compound in a neutralization reaction. Okay, write that down somewhere. Make sure you commit it to memory. Always have water and an aqueous salt left over. Okay? All right, so now I'm going to go back and I'm going to balance because I see that this is not balanced. I'm going to put a 2, and I'm going to erase some of this so that I can balance it, and you can see it balanced. I'm going to put a 2 out front here, I'm going to put a 2 out front here, and then I should be balanced and good to go. Okay? All right. Next up is going to be another neutralization reaction. In fact, what they've done is they've already given it to you, and what they want us to write is the neutralization reaction. So when we write the neutralization reaction, this is supposed to be aqueous. I apologize for the typo. When we write the neutralization reaction, please remember, or I'm sorry, the net ionic equation, please remember that one of the first steps is to dissociate all aqueous compounds into ions. Okay? Once we do that, we cross off what's on both sides, cancel, and then rewrite what's left. And remember, you cannot, don't break up the trio. Solid, liquid, or gas. Okay, leave those alone. All right, so here we go. Let's do it. All right, I know that oxygen is always a -2 charge based on its location. I know that iron, because it's attached to that oxygen and there's only one of them, must be a 2+. Next up, I'm going to recognize that this is a polyatomic ion with a -1 charge. I'm going to recognize this as a individual metal cation, which is going to be a proton of +1 charge. Over here on the right, I already have it. Oops, sorry. I've got ClO4 2, which means that this is a -1, and since there's 2 of them, this one must be a +2. Remember, the charges don't change. This guy, we leave alone. Okay, so all right, so let's rewrite them. So I've got Fe2 plus O2 minus plus H plus ClO4 minus makes Fe2 plus ClO4 minus 2. Oh, this is a -1, sorry. But there's 2 of them. Ooh, what did I forget to do? I forgot to balance this equation. So I have to put a 2 here and a 2 here. Hopefully you see why. I'm sorry. Not a 2 there. Yeah. Because there's 2 on the side and there's only 1 on the side. So to balance this. Also to balance the hydrogens. Oops, my bad. Alright, so I'm going to go back and I'm going to balance these real quick. Alright, and then I've got H2O left over. And that one doesn't get broken apart. Alright, next thing to do is to cross off what's on both sides. I'm on the cancel step. Cancel out the iron, cancel out the perchlorate, and I'm left with the 2H plus O2 minus makes H2O liquid. Alright guys, this is the next one that you're going to do. I want you to do this one on your own. The equation got all messy for some reason. Make sure you balance the equation first. Do it on your own, do it on a separate sheet of paper, write it as lecture question 1. I'll have you submit it as part of your participation for the day. Go ahead and pause it here. Do your thing. And when you're ready, hit play. Oh, that's all. Man, that was quick. All right, have a great day, all. Submit that one question and work on your homework set for me. Have a great day.